Silica. This is an introduction to safe work practices and the health risks associated with inhaling crystalline silica. In this training, you will learn how silica is generated, how silica affects your lungs, jobs that present risk of exposure, how to apply engineering controls, and then the limitations of respirators. This lesson is not going to be complete until you discuss what you have learned with your supervisor. So now let's get started with OSHA and the OSHA rules that apply. There are two rules, one for construction and one for general industry. They're similar in many ways, but there are differences. You should talk to your supervisor about which applies to you. The old rules no longer apply. The new rules are much more stringent with a 50 requirement. The action level is only 25 micrograms per cubic meter. So what is a microgram? Can you get your head wrapped around that? I like to explain it by using a pinch of salt. That's about 1 gram. And if you compare 1 gram on the left to the milligram in the center and then the microgram, what we're talking about today on the right, you can only be exposed to 25 micrograms per cubic meter. That's not much at all. So, this is how silica gets in your body and affects you.
Silica crystals flow into his mouth and nose and down the air passages deep into the lungs. The tiny crystals enter the small, fragile air sacs, where oxygen is absorbed into the blood. Immune system cells, called macrophages, engulf and try to dissolve the crystals, but they are unable to. Over time, more and more crystals build up inside the macrophage cells. The macrophages carry the silica into the walls of the lung, where they die. Scar tissue forms around the dead cells and spreads as more cells die. This damage can continue even after the exposure to silica stops. Eventually, so much scar tissue forms that the lungs can no longer function.
So now let's talk about different applications. Dust from something like concrete sawing. Here we see the time-weighted average on a graph, and you can see the difference from the action level and permissible exposure limit. All jobs that have silica exposure must have a competent person. Here are some examples spelled out in the regulations. Stationary, masonry saws. And in the rule, it tells us what kind of protection you need to have, and what engineering and practice controls you must have in place. Another example is handheld powered saw. After that, it tells us again what we need to do to protect ourselves when you're outdoors or indoors. Each one of these sections is going to tell us what kind of required respiratory protection and the minimum assigned protection factor are required. So what we're really saying is that you need to know what the job requirement is when working with silica. We should look at each job individually and determine the best way to do it. In most cases, we can apply a wet method. Where those are not available, we have to look at other options and only as a last resort are we going to be able to use respirators to protect us. Remember, engineering controls must be in place. What method is typically the way to do it? Vacuum systems may work. There are times when you may need to be tested to see what your exposure is. The methods of compliance: engineering and work practice controls, respirators, and then performance options last. If you're going to wear respirators, you have to understand the different kinds of respirators and what kind of protection you get. And if you wear a respirator, you need to be in a respirator program that does everything that is required in 1910-134. You cannot use compressed air to clean work sites up. It makes the situation worse. The rule also says that dry brushing is not allowed, sweeping in other words, because it makes it worse. So remember, you have now learned how silica is generated, how silica affects your lungs, jobs that prevent risk of exposure, how to apply engineering controls, and the limitations of respirator protection. Time to have that talk with your supervisor. Discuss what you have learned. So that's our training for today. You be safe out there and look out for one another.